category of the combinatorics. In this combinatorics, the important part of the discrete mathematics, that's all that is the counting of the principles. Here, what I mentioned here, permutations and combinations. Here, permutations and combinations, it is a dealing problems we will called as a combinatorics. Yeah, just now I mentioned that is what is a combinatorics and a permutations. It is a combinatorials. Combinations means it is a we want to go ahead further the selections. In the number of objects in that, I want to select that is a few of them. That is how many ways we can be, how many items we can be select. That is comes to combinations. Permutations means it is a how many ways we can pick that is a elements is called as a permutations. Here combinations is the NCR. We have a formula. It is a n factorial by r factorial into n minus r factorial. It is comes under the 10th class and 8th and so on. And the permutations, it comes to the category of NCR means it is n factorial by n minus r factorial is the permutation. N factorial by n minus r factorial into r factorial is comes to the combinations. So these two dealing problems here, some are certain problems, certain kind of the observation of the problems in the computer science or electronics or various industries, all applications are the, it depends on the permutation combination. So we need to learn the concepts of the, these alliance, it is a combined collection of the problems is comes to the category of the combinatorics. This is a one observation for that. Here, basic counting principle in this elements, how many we can be pick, how many we have. That means it is a first we want to know that is a counting of the elements. In this counting of the elements, basic counting principles, it is a, we can deal that it is a number of the problems are number of the problems here we want to be generated on the counting numbers. In that counting numbers, it is a natural numbers are called as a counting numbers. Natural numbers are called as a counting numbers. Mainly, there are the two basic counting principles are there. One is the sum rule, another is the product rule. What is the sum rule means? It is if I have that is a distinct elements. For example, here one is a dancer group and another singer group. Two groups I am selecting. In that is a here all are the distinct. Distinct means it is in this is no singer will be available in the dancer team and no dancer person will having it in the singer team. That is the two are the distinct elements. So here counting of the numbers in the get together we can call it is a mod A equal to mod A1. That is the first team is comes to the A1 singers team and another team comes to the second one. So it is a union of these two is comes to the sum of principles, sum principle. That is called as a mod A equal to mod A1 plus mod A2. Because of no, it is a common elements are there. So that no common elements means it is called as a distinct element, disjoint sets. In that disjoint sets, if I want to make the union, that is called as a sum rule. It is a set of A is comes to the here union of the pairwise disjoint non-empty subsets. It is A1, A2, so on, AN. Then it is a mod A equal to mod A1 plus mod A2, so on, plus mod AN. Here A1, A2, so on, AN are the no elements in the common. That is called as a disjoint principle must be satisfied in the principle of the counting, principle of the counting or principle of the disjunction counting, principle of the disjunction counting. The principle of the disjunction counting is called as a sum rule. Sum rule. This is a first natural numbers. Is the counting numbers. The counting numbers are the two types. In that sum rule is a. It is clearly we called as a principle of the disjunctive counting or disjoint counting. So here, whenever the set of elements are the disjoint, then we can go ahead further. The sum is here how many elements having in the set A and how many elements having the set B. That's total sum is called as our required pair of the disjoint and non-empty subsets. Now here I am taking the generalization A1, A2, so on, AN set of elements we have taken and N of AN groups will be have. In this each group having that is a number of elements. So it is a mod A equal to mod A1 plus mod A2, so on, plus mod AN. Here A1, A2, so on, AN have that is a no elements, no elements in the common. So here mod A equal to we can take that is a A1 union, A2 union, so on, AN. then it is a mod A equal to mod A1 plus mod A2 plus so on plus mod AN is called as a generalized principle of the sum rule. Generalized principle of the sum rule. Now here, for example, it is a set A1 having that is the elements are the N1 and set A2 having that is the elements are the N2. Like it is all the event set of elements. Here previously I considered A set. Here I am taking that is a E1, E2, so on, En are occurred, that is a E set. E set. That is also one representation for that. Here another example, if I take the E events and that E1, E2, so on, Ek are the K mutually exclusive events in no disjoint elements. That is a E1 occurs, that is a N1 ways, and E2 occurs, that is a N2 ways, and Ek occurs, that is a Nk ways. Then that it is a total is comes to the here E1 or E2 or E3 or so on, Ek R. R means union. So it means that is a E1 union, E2 union, so on. En is a occurs, that is N1 plus N2 plus so on plus Nk ways. This is a principle of counting. Now we go for that is any mutually exclusive events. Both of them cannot be occurred simultaneously. It's a note point. Now we can go for that. How many ways are there? Two choice, one letter from the among the set of ABC. How many ways are there to choose one letter from the among that is a set of ABC? Here I will go through by the principle of induction. Why? Because of it is a set is a elements or does not match into the does not contain in the set B and set C. So set A having that is a 3 different elements, and set B having the 3 different elements, and set C having that is a 4 different elements. No common elements we have, so that it is called as a disjoint exclusive events or disjoint or mutually exclusive events. So mutually exclusive events we have set is as per the sum rule directly we can take that 3 plus 3 plus 4 equal to 10 ways. Here this question they will ask for the 4 marks question or short questions that they will ask. So you should write like this. It is only the representation is the when you mention that is a mutually exclusive and applied that is a principle of counting and it comes to the sum rule or not, and what are the addition we have. These 4 steps they will check and give the marks. Now coming to the example 3.3, it is comes to the any 2 disjoint sets will be there. Then it is a mod A union B called mod A plus mod B. That we can be proved by that Z the disjoint events means it is a 2 different set of elements, because of he is asking that is a diagrammatical representation. This is one set, this is one set. No sets are the common. So in this having the sum of the any element, this is having some of the elements. That's some certain elements, number of elements. That number of elements is called as a mod A. And B having that is certain number of elements, so that is mod B. Mod A and mod B represent the number of elements, counting of the elements. That counting of the elements is a way just we can be added. That is called as a mod A union B. Product rule is important. This is a product rule is important. Now, here product rule will come to the principle of the sequential counting. If A1, A2, so on, AN, AK are the non-empty sets. AK are the non-empty sets. Then the number of elements in the Cartesian product, it is called as the A1 cross A2 cross 1. AK is given by pi I equal to 1 to K AI. It means that is all should together the product we should be taken. What is the mod? Mod means it is a total counting of the number that is comes to the product of product means it is a mod A into mod A1 into mod A2 into so on mod AK. That is the product is represented by the pi. Product is represented by the symbolically pi. So here we can see that it is a pi equal to a pi I equal to 1 to K. K elements here, K sets we have. Each set having individual elements. So here mod A1 plus mod A1 into mod A2 into so on mod AK. This rule is called as a product rule. Product rule. Here, for example, if I take A1 having that is a 3 elements and A2 having that is the B1, B2, 2 elements. Here, how many set of elements we can be formed? It means ways is A1, B1 and A2, A1, B2, A2, B1 and A2, B2 and A3, B1 and A3, B2. If I take how many branches we got it here, totally it is a 6 branches. See here 6 counting of the sets we can see here 1, 2, 3, 4, 5 and 6. So if I take the product is comes to the here 3 2 is how much? 6 only. So count is also same. So here 3 branches, it is the first stage contain the 3 elements, and the second branches contain that is a 2 elements. So that it is a 3 2 is how much? 6. So it is comes to the together is a 6 elements. This is a example for the product rule. In this product rule point of view, if I take that is a explanation part, directly it is a generalization we can take. It is a A1, A2, so on, AN are the n distinct elements from A1, and B1, B2, so on are the BM are the M distinct elements from A2. Now I want to take A1 cross A2 equal to union of I equal to 1 to n A1 cross A2. Since A1 cross A2 and the AI cross A2 and the AJ cross A2 are the disjoint, and mod A cross A2 equal to mod A2. Then by the sum rule is comes to the mod A1 cross A2 equal to summation AI into A2 equal to mod A2 plus so on mod A2. So n minus m sums. So this is comes to the product rule of the two sets, product rule of the two sets. It is a mathematical inductions way we can be explained. Similarly, we can discuss. Next, it is a comes to the example. Here in the examination, this is looking like it is a big problem, big theoretical problem. But in that it is, they will ask for the 4 marks question. That is what we have, we should be identifying and the counting of the numbers. Here we should take that is a product form or the addition form, which is suitable for here. Now, I will take this example is a 17.3.5. Here, what is it? 6 students are the contesting in a school elections for the president and vice president. 2 positions. The students with the most number of the votes will be the president, and the students who comes into the second will be the vice president. How many different terms of the president and vice president can be elected? Here total how many number of the students we have? 6 students. In that one president, if it is completed, how many are there? Here vice presidents are they are trying for the 5 students. So it is a total counting is how much number of different terms means it is they have a choice. It comes to the 6 5 is 30. That is our required answer. How many different teams of the president and vice president can be elected? Next, how many bit strings? So what is the strings? Strings means characters. What is the character? Collection of the characters are called as a string. String means it is a ABCD letters will have that all the letters. It is a combined is called as the string. Now it is a bit. Bit string means it is a few of them we consider. Here the how many bit strings are there for of the length 7. Length 7 I am checking means it is each of the 7 bits is comes to the here binary digits that can be chosen into the 2 ways. Yes, since each bit is either 0 and 1, it is comes to the bit means it is a binary digits. Bit means a binary digits into the strings here. Therefore, thereby that is the what is the length is asking 7. So that therefore, by the product rule, there will be the 2 power 7 different bit strings of the length we can be make it. So 120 bit strings we can be create and that it is a binary digits spaces. So that can be we can fill by the string that is comes to the bit strings. Next examples already we have that is already solved problem 17.3.8 in the CQ already bottom we mentioned. Next principles of inclusion and exclusion we will discuss. Principles of inclusion and exclusion. Principles of inclusion and exclusion. It is comes to that it is a if A and B are the finite subsets of the sum universal set capital X, then the mod A union B equal to mod A plus mod B minus mod A intersection B. So you can easily obtain by the proof of using the Venn diagram that we can see. So it is A intersection B is nothing is that then it is a 2 disjoint sets. If we have a something, it is the common term, it is the middle term that will be the subtracted because of it will be repeated from the set A as well as set B, so that it is a one set will be the removed. So here mod A plus mod B minus mod A intersection B. What is mod means a counting. Actually here mod we should not call the mod. It is called as a counting. Counting of A union B equal to counting of A plus count B minus count A intersection B. That is comes to the, it is a principle of inclusion, exclusion principle. Now we will go for that is a one problem. Here, one problem is comes to the here example. In a college, 200 students can speak the Telugu. How many students are speaking Telugu? Here 200 students can speak the Telugu and 70 students can speak the Sanskrit. While only the 40 can speak the both the Telugu and the Sanskrit. So how many students can speak either the Telugu or the Sanskrit? So here I will together it is a set of how many total college students are the here 200 students we have. That no 200 students, but he is asking that is a total students how many. But here 200 students only can speak the Telugu. So that is a more counting of T. Telugu T means it is a more T means it is a counting of T is equal to 200 and counting of the Sanskrit is a 70 and together is it is both are studying both are speaking that is a more it's counting of T intersection S equal to 40. Now we have to determine more. It is a counting of T union S that is called as a principle of inclusion because this is called as a either of total or Sanskrit. Total or Sanskrit. So here, whenever we have a and, at the time go for the product, and whenever we want to go for the or, at the time you go for the addition. This is a rule. So that it is a counting of T union S equal to counting of T plus counting of S minus counting of T intersection S. So here 200 plus 70 minus 40 equal to how much? 230. From the group of the 10 professors, how many ways can be the committee of the 5 members be formed? So that at least one professor A and the professor will be included. Professor will be included. So here, this is one example, important example. Here, I will go through that is a committee formation ways we want to be identified. Here, total how many groups of it is a group of the 10 professors we have, so that it is a 10 professors I am taking. Here, a committee forms that is a 5 members formed, so that at least one of the professors should be there. So here, I can the A1, A2 be the 2 sets of the committees if I form, that is a 5 members including the Professor A and Professor B respectively. The total number of the committees constituted by the 5 professors out of the 10 professors is a 10C5. So 10C5 means it is a 10 factorial by 5 factorial into 10 minus 5 factorial. Factorial means it is comes to the n factorial mean it is 1 into 2 into so on up to n terms. So directly we can take that is it is comes to the 10C5 equal to 252 terms. So also mod A1 it is I will take that is here one professor is already it is entered into the A1. Next we will go for that is A2 identification. A2 one professor left, so the total how many are there? It is a 9 will be there. In that it is a how many we can be selected? It is a 4 can be selected. So that it is a 9C4 is comes to the mod A2. It is count of A2. So it contains the professor A and the professor B respectively. So it is a counting of A1 intersection A2 equal to SC of 8, 3 equal to 8C3 equal to 56. The principle of inclusion and exclusion, it is a counting of A1 union A2 equal to count A1 plus count A2 minus count to A1 intersection A2. So 126 plus 126 minus 56 equal to 196. This is the example. Now here, sometimes he will ask that is using the sum rule, prove that it is a principle and exclusion of the 2 sets A and B, he will ask. So at that time you go for that is a drawing of the figure, it is an intersection part will be there. So it is comes to the, it is a common part is will be there. That common part is a A and B are the A intersection B. It is a figure showing into the middle. Next, it is coming to the figure, it is a A union B equal to what I can take A minus A intersection B union A intersection B union and B minus A intersection B. It means that it is a first part, it is a left side part of what I am taking here. Once you can see here, this is a cursor is showing. This is a first part is called as a minus A intersection B. This is comes to the here B minus A intersection B. Then it is a intersection B will be added. So 3 portions, it is a addition is called comes to the, it is a disjoint, so it's a sum rule. So that it is, I am adding that is a mod A minus A intersection B plus mod A intersection B plus B minus A intersection B. Now, if I take mod A plus mod B minus mod A intersection B. This is called as a principle of inclusion and exclusion of the three sets A and B and C. Now, if I take that as a three elements, if I take the three elements, if A, comma B and C are the any three sets, it comes to the here mod A union B union C equal to mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection C minus mod B intersection C plus it is a mod A intersection B intersection C. This is comes to the whenever we have a three disjoint is the three sets having the it is a not disjoint, non-disjoint. This is a also exists that is by the sum rule we can do that. It is the mod A union B union C equal mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection C minus mod B intersection C plus mod A plus intersection B intersection C. You can easily prove that it's using the Venn diagram representation and sum rule. We can also generalize this as a evo rule for the K and find it subsets of the universal set X. Now theorem, if I take the if I equal to 1 to K and A1, A2, so on AK sets I am taking K finite subsets of the universal set capital X. If I take that as its union, it is a generalization of the previous theorem. So it is comes to the summation of I equal to 1 to K. It is a counting of AI minus summation I comma J. It is a counting of AI intersection J plus it is a summation IJ L. It is a AI intersection AJ intersection AL. So it is so on, so on going up that it is minus 1 whole to the power of K minus 1 of a counting of A1 intersection A2 intersection so on AK. Now proof point of view, it is a mathematical induction based on that it will be we can prove it. It is a problem point of view most important. Now example 17.4.7 is also important. Find the number of integers from the set 1, 2, 1000, where it will be the divisible by 3 is a one of the set and R divisible by 5 is another set. So it is a finding of the number of integers from the set. It is having that is a 1000 elements, which are the divisible by 3 or divisible by 5 is asking. So in this first I will take that it is a divisible by 3 and divisible by 5. What are the elements we have? I am taking here. It is a 3, 5, 6, 9, 10, so on 999. Because of it is divisible by 3 and 1000, it is divisible by 5. We have to find out how many number we have, how many numbers we have for that. So here X equal to set of elements of the 1000, and I'm taking that is a equal to X belongs to capital X such that X is divisible by 3 and B is X belongs to capital X, X is divisible by 5. So the required results in the is counting of A union B before applying there is a principle of inclusion exclusion. We note the following that it is comes to the it is two natural numbers and N and K, so that it is K less than or equal to N. The number is a divisible rule, it comes to the N by K. So it is a greatest integer bracket X is denoted by the rule is comes to the mod A equal to 1000 by 3. It is greatest integer, it comes to the 333. It means that it is a divisible by 3 elements or 333, and divisible by B is it is 1000 divided by 5, it is equal to the 200. It is divisible by 5 elements. So here 2 sets elements we got it. Now common intersection, it is a 3 as well as 5 divisible, both will be divisible, is comes to the as well as a 3 and 5, it will come to the LCM is comes to the 15. So 1000 divided by 15, if we do that, we can get that is a 66 elements are the intersection part. So it is by the mathematical principle of the math inclusion and exclusion, directly I can apply that. It comes to the mod A union B. It means that counting of A union B equal to count A plus count B minus counting of A intersection B. So here I will use that as a counting of A equal to 333 plus counting of B equal to 200 minus 66 equal to 467. Here, this is a example. Next to Pigeon principle. Pigeon principle.
Sir, SAQ and questions ki solutions undava sir.
SAQ question ku solutions meeku chivari page lo solve chesi istaru. Iదే chapter lo chivarlo solve chesi untaru. Sir. Refer chesukochu.
Sir.
Next.
Example 17.4.3. Once again, please repeat, sir. I am not understand, sir.
17.4.3.
3. Yes, sir.
Okay, fine. Here, from the group of the 10 professors we have, in that they want to make that is a A1 team and as well as A2 team.
Yes.
A1 team is a 5 members team they want to form, means one team will go for the 5 professor, one team go to the other 5 professors.
Okay.
Now already it is out of 10, it is the first group I will check. First group, how many professors we have? 10 professors.
Yes.
I want to make that is a 5 professors. So 10C5 is a one team we have, that is the number of selection of the professors we have. That is comes to the 252. It is the A1 set counting elements. It over. Now it is out of 10, one professor already gone through it.
Okay.
How many professors we have?
9.
9 professors we have. Next it goes to the already it is out of 5 professors.
Elements.
One professor has got 4 professors. So here it contains that is a 9C4.
Okay.
So second set is contained that is a 9C4. Now it is an intersection part of both of them. If I check intersection part of both of them, if I check, what is that? It is already 2 persons left. How many professors we have? 8 professors. Okay. Next, already 2 professors are selected.
Remaining 3.
Remaining 3. So because of 5 professors only I should select. So 3 are already 2 left. How many we have? 3 only. So 8C3.
Okay.
By the principle of the inclusion exclusion, what it is saying that it is a mod A1 union A2 equal to mod A1 plus mod A2 minus mod A1 intersection A2. Mod A1 equal to how many? Mod A2 equal to
126. Actually 256 ne off chesaru adi.
Is it clear?
Okay, clear, sir. Thank you.
We go further to 17.4.7 over 8 will be over. Next, we go for the Pigeon of the principles. What is the Pigeon of the principle? Also the known. It is comes to the Dirichlet box principle. We called as a Dirichlet box principle. We called. Sir, what is a pigeonholes means? It is I want to take the n objects. That is n objects I want to arrange into the n boxes. Here I want to take that is at least one box will contain 2 or more objects will be there because of n is greater than m. For example, here you have a 5 objects, 5 balls we have. It is a 3 boxes we have. Each box 1, 1, 1, 1 you are putting 3 over. How many are the pending? 2. The 2 also we can be include that any one of the out of 3 anywhere we can keep. So at least one box will contain already 3 boxes. At least one box will be contain 2 or more objects. That principle is called as a pigeonhole principle. Is it clear? Hello, ma. Terminology is a bigger, it will be look after that. But it is a simple logic is clearly. It is also counting of the principle. Now, here, simple you understand that it is I have a 5 balls. I want to keep into the 3 boxes. Here, one ball is a 1 box I will keep. Remaining 2 will be there. That rest of the 2 also I will keep into the 1 box. Okay. Now you tell me that each box is having that at least 1. Is it correct or wrong?
Only one extra should be put in another box, or
so at least 1. One box will be contain 2 or more.
One box will contain 2 or more. Then
that is called as a principle, pigeonhole principle.
Okay.
Is it clear? So that is generally what we have. That we will be discussed here, and proof also most important. Clear, ma? The pigeonhole principle is also known as a Discrete box principle. Through this
Sir,
is a principle.
1 second, sir. One doubt. So why do we say 2 or more? Because if there are only 4 objects and 3 boxes, then 1 or more, right? One box may contain 1 or more is also a case, right? Why do we say 2 or more only?
More than one, we can say that's all.
Okay, okay.
More than one means it is a more than one means already previously one you kept, no?
Yeah.
Previously one kept, so that it is
Yeah.
a second one
One.
which we count to the, it comes to the 2. Second
Yeah.
one I also added, it comes to the 2.
Yes.
For example, if I take the 10 balls, 10 balls. Hello, ma.
Yes.
10
Sir.
balls. 10 balls, if we will keep into the 3 boxes, what happens?
Then every box there will be more than
2
there
or
will be
3.
at least 3. Yeah. We should
So
account.
then at least one box will contain 2 or
Yeah.
more objects. Am I right?
Yeah. Yes.
So it is a simple thing is comes to the, it is a population is more.
Yeah.
In that all the population in the India can stay into the different states. Each person cannot keep, no. Plenty of the people,
Yes.
bunch of the people will be there. So that is comes to the pigeonhole principle. Sir, what is the need of this one? So this is a situation we can use our convenient into the technology. That's what here we need to learn, that is a pigeonhole principle. Is it clear?
Yes, sir.
Now, what is the proof of the simple form? If the coming to the 17.5, it is a 4 marks sometimes both together. String form and simple form, both forms are 17.5.3. In this 3, any 2 we will be coming into the to mixed up A and B part, it will come to the one long question. Now, what is that? Once again, all of you be careful about it. If n pigeons are the accommodated into the n pigeonholes means boxes. Pigeons means balls. So, if n pigeons are accommodated into the m pigeonholes and n is greater than m, then at least one pigeonhole will contain 2 or more pigeons. This is called as a pigeonhole principle of the simple form. Now, coming to the proof, let us denote that is a n pigeons by the p1, p2, so on pn, and the m holes by the h1, h2, so on hm. And here n is greater than m if p1, p2, so on pm are assigned to h1, h2, so on hm respectively. We are left with the n minus m pigeons and pm plus 1, so on pn. If these pigeons are assigned to the m holes in the some arbitrary manner, obviously at least one pigeonhole will be contained 2 or more pigeons, hence the result is whole. Here what it is saying, generalization only I am telling that. What is that? It is n pigeons, p1, p2, so on pn, pn pigeons I am taking. M holes means it's m boxes, it is h1, h2, so on hm boxes. Clearly n is greater than m. And each one is I am keeping into the one box. We are the left with the how many are the pending are there? N minus m are the extra. Previously I gave that is a 5 balls. It is the 3 boxes. 5 minus 3, how many? 2. That is called as here n minus m pigeons. Remaining is that. So left it is a n minus m pigeons. That is a what are that is a pigeons? Pigeons means balls only. It is a pm plus 1 comma so on m pm pn. That it will be the we have to be keep into the holes. What are that? It is a pigeon holes. It is comes to the assigned to the m holes in the some arbitrary manner. Where which box I want to keep? I will not give any direction here. We can keep any one manner. We can keep the arbitrarily. We can keep. So obviously it is at least one pigeonhole will be contained 2 or more pigeons. Hence the result is good. Generally you can say that. Is it clear? Now I will go further. Amma, first one you understood or not?
Yes, sir.
Right. Now I will go for the 17.5.2. Pigeonhole principle string form. Let q1, q2, so on qn be the positive integers. If it is a sum, if I take Q1 plus Q2 plus so on Qn, minus n plus 1 objects are put into the n boxes. Minus n plus 1 objects are put into the n boxes. Then either the first box is contains at least Q1 objects, or second box contains Q2 objects, and so on. N boxes is contains that is a Qn objects. So what is the extra will be there? That is extra is I'm keeping into the minus n. All Q1, Q2, Qn, all keeping into the boxes. Here, so here all n total it is how many we have? First box, second box, third box, all will be the, if I take that is a Q1 plus Q2 plus 1 plus Qn. The extra will be there some minus n plus 1. This is comes to the here pigeonhole principles of the string form. We called as the string form. Now here it comes to the second box contains at least Q2 objects, and n box contain at least Qn boxes. Now proof point of view. Here we prove that is using the method of the contradiction. Contradiction way I will go for that. It is a proof. Suppose this is a not true for this statement. If I take, what happens? It's the ith box contains at most Qi minus 1 objects. For I equal to 1 to so on n. Then the number of objects contains the n boxes. If I take, first box is a Q1 minus 1, second box Q2 minus 1, so on Qn minus 1. Total how many are there? Q1 plus Q2 plus so on Qn minus n, which is 1 less than the number of objects distributed. This is only the contradiction. So directly we can conclude that it is a here the suppose that it is a clearly we can say that Q1 minus 1 plus Q2 minus 1 so on Qn minus 1 equal to Q1 plus Q2 plus so on Qn minus n, which is 1 less than the number of objects distributed. This is a contradiction, hence that is a statement of the principle must be the true. What you are taking the contradiction is wrong, so that it is clearly taking that what it is there, it is correct. Next, to generalized principle. If I
Sir,
take that,
sorry to interrupt, sir. This string form is just another form of the same principle, or because with
actually, okay, this is a reverse and it is a opposite bias. It is comes to the what is it? Here boxes here already, just a small example. 5 balls I am keeping into the how many boxes? 5 boxes, 3 boxes.
3 boxes.
Okay, 3 boxes. Now you take that is a how many elements objects we are taking? First one is only 1 will be there. First box, second box also 1 will be there. Third box is 1 will be there. Total how many are there?
3 have fitting, 2 are left.
2 are left. Okay, first I am talking about that is how many are there? 3.
3.
Okay. Total elements in that I will take that is a total how many elements we have. I don't know. N here Q1, Q2, Qn. If I take that is a n elements. Here I am taking that is a 5 Q1, Q2, Qn is n elements in the different boxes. Here 5 balls or 5 objects. 5 objects. I am keeping into the 3 boxes. It is a how many 2 are the left you mentioned. Okay. Each box having that is a 1, 1, 1. What is the extra will be there? What is the extra will be there? That representation is a clearly the total plus what is the additional is required. Okay. That formation is comes to the string form. That's all. It means that is a both are the same. Previous what is a simple form is there and the string form both are the same. Okay. How you are getting this one means here one box will be there. Already 1 will be dropped. How many? How much space will be there? Do you know?
2 need to be accommodated. 2 more.
One. Box is how much empty will be there? Do you know?
No.
No. So regarding that, speaking is called as a string form.
Okay.
Okay, but it is a fitting after counting is a clearly satisfies the both ways are the same.
Okay.
Simple form, how many are you are fitting? Extra you are putting, no?
Yeah.
Which box is empty? In that you are putting. Same way here also, here reverse bias, how much boxes we have, that boxes, it is how much are the empty will be there. Empty spaces are occupied, that will be represented here. Q1 plus Q2 plus so on Qn minus n plus 1 objects are put into the n boxes. Clear? అర్థమైందా?
మైనస్ n ప్లస్ 1 ఎందుకు వచ్చిందో తెలియట్లేదు సార్. అంటే మైనస్ ఆఫ్ n మైనస్ 1 అది
మైనస్ ఆఫ్ n మైనస్ 1.
అంటే ఏంటి సార్? ఫర్ ఎగ్జాంపుల్ మనం తీసుకున్న ఎగ్జాంపుల్ బట్టి చూస్తే సో Q1, Q2, Q3 ఆర్ ద ఐటమ్స్.
Correct.
Okay, so those items, first we have n spaces, one each fill చేసేసాము. So extra items అంటే ఎగ్జాక్ట్ గా ఏంటిది ఎక్స్ట్రా స్పేస్ ఎంత ఉంది అని
అంటే ఇట్ ఈస్ అ స్పేస్ ఉంటేనే ఆక్యుపై చేస్తుంది. అర్థమైందా? ఇట్ మీన్ దట్ అట్లీస్ట్ Q1 items for the box 1, at least Q2 items for the box 2, so on up to Qn objects will be the fit by the last box. That will be the fitted correctly, exactly how many we have, that many we can fit it. Extra more will be there. It is not possible. That is the meaning of the string form.
Okay, sir.
It is indirectly we will speak about it. Okay. So what we will do next further, that what is the balance will be that what we will do, that is a separate thing. We have some procedures that way we can follow. Okay. Now proof point of view also I am taking that is a Q1 minus contradiction way I am proving here. So suppose that it is not true, then ith box is contains at most Qi minus 1 objects for I equal to 1 to so on n. Then the number of objects contained in the nth box cannot be, nth box can be at most Q1 minus 1 plus Q2 minus 1 plus so on Qn minus 1. If we added Q1 plus Q2 plus so on Qn minus n, which is 1 less than the number of objects distributed. So it is that one also I am adding, so that it is a Q1 plus Q2 plus so on Qn plus 1 minus n plus 1 objects. This is a contradiction. Hence, the statement of the principle must be the true. That's all. Okay. Here, for example, simple form of the pigeon is obtained by the string form. Someone asked the doubt, no? You can clarify here. Q1 equal to 2 amma. 2 objects, 2 spaces. Q2 having the 2 spaces. Up to how many we have? 2 spaces.
n boxes, so 2n.
2n minus n plus 1. How much? N plus 1. So pigeon hole will be the n plus 1. Pigeon hole means boxes. Boxes must be the n plus 1 boxes we have. That I want to say. Clear?
Okay.
Based on the balls, I want to, how many boxes I need, that is n plus 1. Any doubt will be there? Shall we go next?
Yes, sir.
Right. Now, generalized principle of the generalized pigeonhole principle. If n pigeons are accommodated into the n pigeonholes and n is greater than m, then one of the pigeonholes must be contained at least n minus 1 divided by m box plus 1. It is called as the greatest integer of n minus 1 by m plus 1. Pigeons will be there. It is a mod x is the greatest integer equal to x. So contradiction is suppose pigeonholes contains at most to n minus m and n minus 1 m pigeons. Then the maximum number of the pigeons in the m pigeons is a m into mod n minus m by m is less than. Both side I am multiplying with m into n minus 1 by m cancel n minus 1. So it is a true for that is the n pigeons. Hence, it is result is folded. That's all. This is the generalization. Sir, it is how we are getting means it is both. It is a simple form and a string form. Both combination is a generalization we are giving here. 17.5.3. Yeah, these three you should be remembered. Next, I will go for that. This is a principle. What is it? This one example. There are the n pigeonholes are occupied by the kn plus 1 pigeons. By kn plus 1 pigeons. Where k is the positive integers, it proves that is here at least one pigeon occupied the k plus 1. K plus 1 are the more pigeons. More pigeons. So here, how many balls we can accumulate? It means it is a k plus 1. More k plus 1 or more we can be occupied. That is only the process of this one example. Now example, sir, here above you said that these are the three. Now how I can be understood that it is a mathematically. So here I am giving the one example. Here 17.5.5. Here okay, there are chosen at the random. It is their sum is at 19. Their sum is 19. Show that at least one number is a 7 or more. 7 or more. So 7 or more means it is how many are there? Kn plus 1 equal to how much? 19. Kn plus 1 equal to how much? 19. 3 numbers are chosen at random. 3 numbers are. It means that identify that is the 3 numbers are the pigeons. We identify the sum is a 19. The number of the pigeons is 19. From the above example, what is the kn plus 1? We have it that is a k plus 1 pigeons. So that I will go through it. It is how much? It is a kn plus 1 equal to 19. N equal to 3 because of he mentioned that is a 3 numbers. So here 3k plus 1 equal to 19. 3k equal to 19 minus 1 at 18. Next kn equal to 3k equal to how much? It is a 18. K equal to how much? 18 by 3. So it is a k equal to 6. Therefore, it is a how many pigeons we can take? It is a 6 plus 1 pigeons. It will be the exist. Therefore, it is at least one pigeonhole that contains at least a 6 plus 1 pigeons. There is one number. It is greater than or equal to the 7. Greater than or equal to 7 will be there. This is one example. Next example 2. The number it is a 1 to 10 are arranged randomly around the circle. Around the circle. Here, there are the 3 consecutive numbers he is arranging. Whose sum must be the 17. Whose sum must be the 17. Now it is all the consecutive numbers. I am taking 3 groups. Here, if I take that is a 10 groups. Here, then it is a sum comes to the A1 plus A2, so on plus A2. It is all the 10 groups because of he arranged the 10 numbers, so that it is all 10 groups I added. What happens if I added that comes to the 3 times of A1 plus A2 plus so on. So 3 times of 1 plus 2 plus 3 plus so on means it is what is n into n minus 1 by 2 is a formula. So here 3 times of that if I take 165 I can get. 165 means already it is a 10 triples we have. So that divided by 10 means it is clearly we can get that is a 16 possibilities we have. So 16 into 10 is equal to how much? 160. Then it is a 165 is greater than 160. So that it comes to the pigeonhole principles will come to the 16 plus 1 equal to how many? It is at least 16 plus 1 means 17. 17 pigeons holes will be available here. That is a example for here. Next example 2 also will go for the same. You can study. And generating functions. Yesterday I mentioned the generating function comes to the this is a function is the sum of a of a equal to a naught plus a1x plus a2 x square plus so on plus a n x square. So summation n equal to 0 to a n x to the power of n. Now that representation is called as a generating function, infinite sequences. Here coefficients are the a0, a1, a0, a1, a2, so on an. Now it is a representations here. Sometimes he will give like this. It is a coefficients are this one. Then it is a generating function he will ask. So it is like that we can be right. So it is a 3, 2, 1, 0, 0 he will go. What is the generating function he will ask? So that it is directly 3, 2x plus x square. So on like that we can be write it. So how many we have? That is a total here. Now it is a sum of all the terms is also represented. For example, here 1, 1, 1, 1 I have given 1 into 1 plus 1 into x plus 1 into x square plus so on. Here infinite terms. So dash, it is a finite. Previously it is a finite. It is also infinite. Finite also I can take. Here infinite will be there. At that time, generative function will be the observation will come to the infinite number of terms. So that 1 plus x square plus so on. This is a series of the term 1 by 1 minus x. So 1 minus x whole to the power of n formula is comes to the 1 plus x square side like that. So this is a formulas and their corresponding sequences. So sequence based on that polynomial we want to be identified. Generative function we should be developed. So here operating for the generative function also will be the same. Here any constants, if I say C0 to C1, here rules will be have. Here this is a scaling rules. Scaling rule. How many rules? It is a operations on generating functions. Discuss about that operations on generating function. If we mention that, it is a we can go for that is all the rules we should be discussed. What is it? It is a scaling rules. It means that any constant will be there. Constant I can take common. Next, it comes to the addition rule. Here, sum of the two numbers, if we take that is a two separated two sequences. If we add it, then it is a two sequences separation we can do. That two separation of the sequences, so we can establish that is a generating functions two separately, and we can add it. Next, right shifting theorem. Right shifting also we can be used. Right shifting means it is x to the power of k into remaining rest of the terms we can take, so that it is also a of x. Derivative rule. Derivative rule means it is all the will be the d by dx of the derivative also I can take. That is a dash of x we can represent it. Next, it is examples of the derivative. This is also one of the examples of the derivative. Next, it is comes to the product rule. Product rule means it is comes to the any two sequences having the product. At the time we can take that is a generating functions c of x equal to a of x into b of x. So this is a representation. So we can see here product form means is inside it is having the table formation. Next, method of calculation of the x generating function. This is comes to the operations of generating function. Previously we discussed 17.6.4. 17.6.5 will come to the same way. It is a representation for the generalization in terms. Here you will ask the find the coefficients of x to the power of 16 in these terms of. So it is a sequence formations. I will take n1, n2, so on nn. Then it is a how many we can formation we can take that it is comes to the sum is a 21. Next to 2 how many we have, 5 how many we have. The product rule, if we apply, then I can get that is it is a equal to the 9. Just once you can refer this one. Next, it is coming to the rule number 6. It is comes to the conventional rule. The conventional rule will come to the here union formations. It is a disjoint sets we have. It is a union will be comes to the it is a union B equal to product formations. We can write a of x into b of x. That comes to the convention rule. The convention rule example is comes to the find the coefficients of this one like that. So directly here we can take that is x y square whole square means it is a what are the coefficients based on that directly we can take 2 into here -1 into -2 and whole square -2. That -2 will be the multiply with the 4 factorial by 2 factorial. So 4 factorial how much? This is a 4 factorial. This is a 2 factorial. So 4 factorial by 2 factorial into coefficients we can check. Coefficients means it's a power 2 here, so that directly we can take this is the answer. Next, this is the overall idea about it. What we have. What we discussed here today class, we discussed about that is a what is the counting of the numbers and sequential formations and permutation combination, which is a combinatorics coming into the pigeonholes, pigeonhole principles. It is a 2 sets and 3 sets and a generalization form and counting of the principles. Then after that it we go for that is a generating function. Generating functions, it is a various operations how many we have. This is a total we discussed in this class. Okay, anyway we meet in the next class into the another topic, another chapter. Okay, anyone have any doubt? Okay. Okay, I will wind up the session. We meet in the next class. Right.
సార్ ఎగ్జామ్స్ ఎప్పుడు ఉంటాయి సార్?
మీకు కమ్యూనికేట్ చేస్తారన్నారమ్మా మేడం, కమ్యూనికేట్ చేస్తారు. ఓకే చెప్పారు మేడం.